8th graders, real quick little remote assignment for you guys to do today. It's fairly simple and it shouldn't take you guys very long. The longest part is probably listening to me explain how to do it. But other than that, you guys could probably glean what you need to know out of just the instructions that I put in here. So I just want to go over a few quick things, show you guys how to do it. I'll show you the example, and then I'll show you guys how you can kind of check your work as well. So this is called counting atoms and molecules. In your learning targets, I can define and build a molecule. I can identify the number of each type of atom in a molecule. So first of all, let's talk a little bit about molecules. So we've been learning about molecules this week. A molecule is 2 or more atoms or elements combined together to form a substance with unique properties. So it could be 2 atoms of the same element, or it could be multiple atoms of different elements to form a molecule. All right, so here is an example of a molecular formula right here. We've got 4Na-C2H3O2. Okay, notice the capitalization. We've got Na here. The capital N is, or excuse me, the N is capitalized, but the A is lowercase. That means that's one element right there. We've got one element right here, one right here, and one right here. Okay, so these are the elements that make up this molecule. This molecule is made up of sodium, Na, carbon, capital C, hydrogen, capital H, and oxygen, capital O. Notice how the atomic symbols are capitalized. So again, we've got a capital N and a lowercase a. That means it's just one element. But if you guys see maybe 2 elements that are together that are both uppercase letters, that means they're 2 different elements and not something like sodium with 2 letters. Okay. All right, moving on to the next slide. Let's talk about these little numbers down here, which are called subscripts. These subscripts tell us how many atoms of each element are in one molecule. So if we're just looking at one molecule of this is sodium acetate. Okay, one molecule has 1 sodium. Okay, notice that there's not a little 1 written after it. Just by writing the atomic symbol Na itself, that tells us that there's at least 1 atom available. And if we don't say that there's any more than that, then we're just going to assume 1 atom of sodium, 2 atoms of carbon, 3 atoms of hydrogen, and 2 atoms of oxygen. And again, that's just in one molecule. Okay, so let's move on to the next slide. I'm going to tell you what this big number in front means. This is called the coefficient. It tells us how many molecules we have. Okay, so the last slide we talked about just the number of atoms in one molecule, but in this case we have 4 molecules of sodium acetate. So this number in front of the molecule is called the coefficient. It tells us how many molecules we have. In this case we have 4 molecules of NaC2H3O2 or sodium acetate. Okay, so if you guys were given this and you have a number in front, that coefficient tells you how many molecules you have, and I ask you guys to count how many total atoms are, you guys would take everything you see as far as the subscripts go in this and multiply it by 4. So even though in one molecule we only have 1 sodium atom, we actually have 4 molecules of this. We'd have 4 sodium atoms. Okay, in one molecule we have 2 carbon atoms, but because we have 4 molecules of this, we're going to have 4 times 2 is 8. So 8 total carbon atoms. Okay, 4 times 3 is 12. So we would have 12 total hydrogen atoms. And 2 times 8 again is, or excuse me, 2 times 4 again is 8. So again, we would have 8 oxygen atoms. Okay, moving on to what an example would look like with this. This is what your guys' questions will look like, where you guys have the formula up here. You guys will see the coefficients and the subscripts, and then you guys will fill out this column of the table. This one's your example, so it's already done for you. So the number of molecules, you would look directly at the coefficient right here and say, all right, we got 4 molecules. Number of sodium atoms, so in one molecule we have 1 sodium atom, but we have 4 molecules, so 1 times 4 is 4. Okay, number of carbon atoms, 8. Again, 2 times 4 is 8. Number of hydrogen atoms, 3 times 4 is 12. And number of oxygen atoms, 2 times 4 is 8. All right, so for the most part, I keep it fairly simple for you guys. Here's your first one. This is a molecule. So even though there's only 1 element available here, we have 2 atoms of it, okay? So how many molecules? We don't have a coefficient in front, so we're just going to assume 1. And then how many fluorine atoms? F2. So we have 2 atoms in that. Okay. So that's your guys' first one. I built in there, you guys, a little helper if you guys need. So you guys can go to the PhET Build a Molecule Playground. So go ahead and right click this link and open it up. And you can go into this playground, this third option on the right once this loads. And you guys can build this in the playground if you're having a hard time visualizing. Really, you don't need it for the ones where you guys only have one molecule. But when you have more than one molecule, sometimes it's hard to visualize and you guys just want to be able to count, of course. Computer seems to be very slow right now. All right, that took me a second to get it loaded, but you guys can go right into this playground right here. And then across the bottom of this playground, you guys will find a selection of different elements that you can use to help you build. Our first one, like I said, is F2, so you guys would go find the Fs, and you guys would need 2 of them. So you guys can click and drag that out and say, all right, I got molecular fluorine right here. Okay, again, this isn't necessarily super helpful on the ones where you guys only have a single atom, but if we scroll down, we've got other ones where we have multiple atoms. So let's take a look at this one. If we go ahead and read this, we can find bromine in our little trays. And in this one, we have 2 bromine. So we're going to go 1, 2. So there's 1 bromine molecule. Let's see if we can find more bromines for us to build. Okay, maybe not. Okay, so you guys would see, all right, here's 1 bromine molecule, and then if I were to make a second one, which it doesn't look like I have any bromine available to do that, so I might change this example for you guys. So you have, let's do 2H2. There we go. So this is going to be the number of hydrogen atoms for you guys. So that one you guys have enough to build, so you guys can say, all right, here's 1 molecule of hydrogen. Here's a second molecule of hydrogen. How many total atoms do we have? 1, 2, 3, 4. Okay, so that kind of shows you guys just a little bit on how you guys can use the PhET Build a Molecule Playground. Again, that really only helps you guys a lot on this. Make sure you guys are picking little trays that have enough stuff for you to build. So you guys might want to pick the ones that have the most items for you to build. Okay, all right, so that's your guys' assignment for today. Again, it's fairly simple. And there's only a couple examples for you guys to do, and once you're done, you can go ahead and hand it in. If you have any questions, let me know. Hope you're having a great day. I'll talk to you soon. Bye.